The math on the Doppler effect is definitely a little bit more involved. What happens is we hear a new frequency. What we hear is the old frequency multiplied by this weird ratio of speeds. On the numerator, we have the speed of sound. On the denominator, we have the speed of sound plus or minus the speed of the object. Now here's a little trick to help you remember. If you're in front of the car in this question, that means the car's coming towards you. That means the distance between you and the source of the sound is decreasing. Since the distance between you and the sound is decreasing, we're going to use the negative in the equation. So I'm going to fix up my equation. The negative goes in here. If it were a different question, if you were behind the car and the car was moving away from you, then we would use the plus. So the fact that the distance is getting bigger, use the plus sign with that. Conceptually, I know that I should, when I'm done my math, end up with an answer that's larger than 800 hertz. Since it's driving towards me, those wavelengths get squished together, which means a higher frequency. So mathematically, I need to end up with a number bigger than 800. If I goof up and get a number smaller than 800, that's a good indicator that you used the wrong sign. So if that ever happens, that you get a frequency that's different than you expected, maybe run through the math the other way, see if you get a more reasonable answer. For this one, it's actually, now that we've done the thinking about the plus and minus, this is kind of what I would call a plug and chug. I know the frequency is 800. Also on the numerator is the speed of sound. In this case, it was given. Maybe another time I would give you the temperature and you could find it out. The denominator under the whole thing is the speed of sound minus the speed of the object. Oops. The speed of the object was 15. I ran this through on my calculator. The numerator turns out to be a big number. And the denominator, you could probably do that in your head, 325. That means that the perceived sound, I'm using that little dash just for the other frequency or the new frequency, but how it would be perceived, how someone outside the car, in front of the car would hear it. My calculator is spitting out, when I round it off, 837 hertz. It's higher than 800 as expected, so I'm confident that that's the right answer.